Consider the following pulse transfer function, which is right here, 1 over z inverse times 1 minus 0.7 z inverse. Identify the finite poles of this transfer function on the z plane. Okay, now before we get into this, let's try to read through some of this text right here. For those of you who don't know what the poles are, well, the poles of a transfer function are frequencies which are values of s or z for which denominator becomes 0. Okay, zeros of a transfer function are frequencies which are values of s or z for which the numerator becomes 0, right? So poles are for which the denominator becomes 0, and for zeros, the values of s for which the numerator becomes 0. Now we have a function here. It's a pulse transfer function in a z. Here's a z transformation of it, and all we need to do is I'm just going to simply transform it into something where we can find the value of z such that when I do that, because it says I identify the finite poles, so such that if I put the value of z here, that the denominator becomes 0. Okay, now the above equation can be written as, if I take this z inverse in the numerator, so this becomes z over 1 minus 0.7 over z, right? If I take a least common factor here, numerator will stay as it is, and this becomes z minus 0.7 over z. This z is going to move over here. So the above equation can be further transformed as z square over z minus 0.7. Now the question here, what should be the value of this z here such that the denominator becomes 0? Well, if z is equals to 0.7, and if you put that equation over here, the denominator will become 0. Therefore, identify the finite pole of this transfer function on the z plane. It's actually this right here.